This episode of the HVAC School podcast is made possible because of Testo and Carrier. And I just want to thank Testo and Carrier again for really making HVAC School what it is. I've been able to dedicate a lot of time to this project. I have some guys who make fun of me, like maybe this is all I do. It certainly isn't all I do. As you know, I have a business that I need to run. But this does allow me to free up some time to create these free resources and just dedicate some space in my schedule. And even getting a little bit of editing support I've been getting lately from some people helping me edit the podcast. And that's all because of the support from Testo and Carrier.
And now the man who never leaves the disconnect out or the caps off, Bryan Orr.
All right, so maybe I have left the caps off a time or two, and maybe I have left the disconnect out once, maybe twice, tops. Okay, maybe 10 times. But that's definitely the most. Today on the podcast, we have a man who I'm certain has never left the caps off once in his life, and that is Corbett Lunsford. And maybe it's because Corbett Lunsford is not actually an air conditioning technician, but rather a building performance technician. But if you haven't had a chance to see Corbett Lunsford's stuff online, he really has high-quality materials, and really the intersection of building performance and air conditioning, the distinction between the two, is getting more and more hard to tell the difference. So we're going to really get into some building performance stuff here. If you don't know what a blower door test is, today is your day. So I started off just by asking Corbett, why would you even consider getting into building performance?
Everybody wins.
So today on the podcast, I chased down Corbett Lunsford. I've been stalking him outside of his house, outside of his tiny house, as it turns out, that he's been pulling around America. I'm the guy in the scooter who's been following you with the weird hat, and I've been tracking him down, trying to get him on the podcast, but I'm thankful that he is finally here. So thanks for coming on, Corbett.
I am delighted to be here. Thanks very much, Bryan.
So for those of you who are listening who are either technicians or owners of contracting companies, or you work for HVAC distributors, I think I just named every single person who listens to this podcast other than my mother. You may or may not know Corbett Lunsford. If you don't know him, then I would strongly suggest right off the bat that you watch some of his videos on YouTube because they're fantastic. Even if you're not into building performance, which is what we're going to talk a little bit about today, there's just really, really good information about airflow testing and balancing and pressure differential and all that type of cool, groovy HVAC airside stuff. And so that's kind of how I started following some of what Corbett does. It's all very well produced, so I would suggest that you go take a look at that. You can actually even pause this on your phone right now. Just hit pause, go watch a couple videos, and then come back, and then you may enjoy this a little bit more. But today I just wanted to get a brief overview of what building performance is, some very practical things that you can take away and maybe apply in your business possibly. But before we do that, if you wouldn't mind just sharing with us a little bit about who you are, Corbett, and kind of how you got into this business in the first place.
First of all, thank you very much for the delightful intro. And I appreciate that you said I'm polished, because I run a podcast too that is a total amateur hour compared to your podcast. What I'll tell you about what I do is first that I'm a new guy in the industry. I was only doing this since 2008. And essentially what I do now is whole home performance analysis. I do energy modeling and computers. I do performance testing. I'm very, very testing heavy. And then I give recommendations and give people prescriptions basically to help solve problems or prove that they got what they paid for. What I did before was music. I played piano for dance companies and dance schools. So I didn't know anything about what a plenum was before 2008. And to me, one of the strengths that I bring in what I do is the fact that I'm a new guy. Guys who are listening to this who were trained by their dad, who was trained by his dad, have 3 generations of knowledge, and they are not ever allowed to ask questions about what they do. And I think that that is a crying shame, because right now is the time when everybody has to be asking questions because the industry is changing, and especially HVAC is in the hot seat. Like, there are going to be lots of bad things happening to HVAC companies and professionals in the coming years because of codes, because of the new techniques that we're using for enclosure sealing, all the new devices and gadgets that people are putting in, their indoor kitchens, their special bath fans, their ERVs, and like all this stuff. And of course, now ventilation also is a big deal. So I think that the new guy mentality of like knowing that I'm an idiot and that I have to ask questions to even learn the first thing about what I'm talking about was always a strength. And that went straight into the tiny lab, the tiny house that you mentioned at the top. I've never built a house before. And what we did was take this tiny house on wheels to 26 states and told 7,000 people, normal people, that, hi, my name is Corbett. I'm an idiot. I've never built a house before. And this house outperforms any home in your entire state. In 26 states, I said that. And of course, no one can argue with me because I have all the metrics on what my house is doing as far as the pressures and the airflows and the radon levels and the carbon monoxide and carbon dioxide and all this, blah, blah, blah. We could make a list of a million things. It's not hard to do this stuff. It's not rocket science. That's why I have a YouTube channel. Like, you can literally learn to do static pressure testing in 5 minutes if you watch one of the videos on my channel. It's not super hard. It's hard to actually do it. And we all talk about wanting to do a better job, but we don't actually do it. And I think that it takes somebody who's really feels dumb from the beginning to ask the right questions and get to the point where asking questions is a part of my normal job day in and day out. And that makes me feel great because I meet people who say, secretly, I've never seen anything like this before. And I'm like, hey, I've never seen anything before like it either. No one has. Don't worry about it. It's okay. So I find my work very refreshing. And I get to help people in new ways, and I get to, learn new things all the time. And I think that is something that all of us in the construction industry should be trying to achieve, because right now is the time when we have to be asking these questions.
All right, so I'm going to do a total left turn here. The way that you just presented yourself is something that I think technicians out there need to hear. There's going to be a couple different categories of people. There's always two different types of people in the world, right? But there's going to be one category of person who's listening to this who says, that's really refreshing, that Corbett's willing to admit what he doesn't know. And then there's going to be another group that's like, well, this new kid, he doesn't know what he's doing. Why can't I do that kind of thing? And so I read this post the other day on one of the HVAC technician groups on Facebook. And it was a guy who was 55 years old, and he injured his back or something. And essentially his complaint was that why aren't there more jobs for technicians where they don't have to break their backs? And what you just illustrated through the way that you talked about how you got into this, and going from where you were in 2008 to where you are today, I mean, anybody can follow you online and see that not only are you an expert at what you do, but you really do approach it in a new and kind of fresh way. And you actually do have some skills at this stuff. It's not like you're just making this. It's not like you're some dummy at this point. So you can say that, but the reality is you really are an expert in your field. For the technician who's been doing this for all these years, you have an amazing opportunity to learn new things, do new things, get into industries you've never been in that don't require you to break your back, so long as you're willing to be humble and learn new things. If Corbett can go from where he was to where he is today by just being open-minded, then so can you. So the message here is, so maybe it's a little rah-rah woo-woo, but the point is that it's the similar path that I walked from being, a maintenance technician, whatever it was, 16 years ago, to now where I am today, owning my own business with 50 employees. To what Corbett's doing, where in 2008 knowing very little to now being an expert in the business, requires humility. It requires the ability to say, I don't know everything, and there's lots of stuff that I can learn from anybody, from somebody who's been doing it a year to somebody who's been doing it 30 years. Okay, I'm getting off of my soapbox now, but I wanted to at least say that because I honestly believe that's what makes, or at least it's a big part of what makes you so successful, Corbett, is your ability to be humble in the marketplace and say, there's things I know, there's things I don't know, and I'm always open to learning.
Thanks, Bryan. Yeah, even I lug blower doors and duct tightness testers and all this different equipment into my clients' homes. And I for sure carry heavy equipment too. So I know that that's a part of the job, but there are ways to do, more thinky work and also to take it easy on yourself and not rush around too.
All right, so let's get into some practical, let's start with the kind of the high level here. So what is the market for building performance in the first place? Who is hiring people like you to do this type of analysis?
Okay, so in the first place, let me tell you that the market that everyone, one of my things is constantly trying to remind people that I'm not really from the inside. And I think that one of the reasons I do that is because the way that people are taught to think about home performance, the whole kind of supposition that it comes from energy efficiency gets you on the wrong track immediately. Most of the people who are in home performance came through the door of energy efficiency. But really, if you look at it, what I'm trying to teach normal people and pros around the country and also around the world is that there are three main ways that you can use home performance testing. And testing is the whole thing. It's not an aspect of home performance. The testing is what makes someone different. So if you, first of all, have a complex problem in a home, the classic one in air conditioning land is summertime. Top floor is hot, basement is cool. I have to move out of my top floor bedroom into the basement in the summertime because I'm so uncomfortable, right? That's the most extreme version. They call the air conditioning guy, and the air conditioning guy says, well, maybe the air conditioner's not working properly. Maybe I should upsize. It's not an air conditioning problem. It's a problem with the interlinking of the air flows and the air pressures and the heat bleed in the house. And it results in stack effect, which reverses because you're cooling air, it becomes denser, blah, blah, blah. Don't worry about the complex science behind it, but basically it's a complex problem. It seems very simple, it's very complex. So that's the first thing. If you want it done right, and by the way, if you're looking to target leads for this, do not target first-time homebuyers or first-time homeowners. They don't care. They think that fixing the problem themselves, or then, when it doesn't work, going to their brother-in-law who knows a little bit about houses and trying to have him fix it, and then hiring a cheap contractor, and then finally, after years of trying to fix this thing, hiring a good contractor, they think that's worth it. Somebody who understands that homeownership can be a nightmare just wants to find somebody who can guarantee to fix the problem. And the only way you can guarantee to fix the problem is with diagnostics, because you don't know what's going on unless you test. Second main way that you can use home performance testing is if you are planning home improvements. Anybody has a little pile of money, they're going to start improving either a residential multifamily building or a single family home. And they want to know how to prioritize what they're doing, and also that they are making sure to take advantage of all opportunities for improvement. If you're going to skin the kitchen, you might as well add insulation. Not all insulation is alike. Not all insulation installers are alike. You want to make sure to do it the right way, and quality control is what this is ultimately about in that case. And then lastly, if you're building or buying a home and you want to make sure you're not getting a lemon, testing will help you. Now, you notice that in those three things, we talked about solving complex problems, improving homes, and building homes and buying homes. I didn't mention energy efficiency anywhere. Energy efficiency does not enter most of my clients' minds. It's all about finding cost-effective, time-effective, energy-effective, elegant ways to tune the two main systems in any home. The first system is always the enclosure. That's bad news for the HVAC guys, because most HVAC guys are not trained in enclosure stuff. The enclosure is made of the air sealing and the insulation. And the other system, which is subservient to the enclosure, is the engines. And the engines are the heating, the cooling, the dehumidifying, the ventilation, the water heating, all of that stuff, and the stuff that moves those pipes, ducts, etc. So if you take those two systems and you test both of them comprehensively, you essentially know everything you need to know about any home. And you can't hide anything in construction anymore. I can find out anything about how a home was constructed as a pretty new guy in this field, only having been doing this for less than 10 years. I could tell you exactly what went wrong in the construction of a house, which should terrify a lot of builders, should terrify the HVAC community, because you guys are required now to do manual J, manual D, manual S. In basically every state within the next couple of years, when the energy codes become more and more adopted by all of the states, which they're required to do. So all of that stuff basically goes to saying the entire construction and the entire improvement industries in the world will be utilizing diagnostics in the future. And it could be 5 years, it could be 10 years, it could be 20 years, 50 years from now. It doesn't really matter. You want to start testing stuff, because this is where everything is going. We live in the information age, and metrics are what govern everything. Google is who it is because they get metrics. If you don't have metrics, you have nothing, and you have no way to stand up against somebody, for example, like me, who is a former ballerina piano player. I will win an argument with any professional, no matter how long they've been doing what they're doing, if I have more information about what is happening than they do. And that's sad. I don't want to live in that world, but that's the world that actually exists, because people love metrics. By the way, just to digress, I'm sorry I'm on a rant right now, but if you think, do Americans, let's just talk about Americans for a minute. Do Americans love metrics? Most of the people that I would present for who are professionals would say no, and they'd give a big, cat call from the back. And then I would, okay, that's fine. If you think that right now, let me ask you two questions, and you're going to change your mind. Number one, is anyone wearing a fitness tracker? And if you know anybody who wears a little fitness tracker, the thing they always want to tell you is how many steps they got in today. And then secondly, do you love sports? America is crazy about sports, and sports, guess what, is all about stats. If you don't have stats, you don't have sports. So now I'll ask you again, do Americans love stats and metrics? And the answer resoundingly is yes. We have been giving them terrible metrics for homes. It's all about energy efficiency, which nobody really cares about. If you talk about performance, if you talk about air quality, if you talk about kids' health, if you talk about the smelliness, the sound in your house, the comfort levels, the control that you can give people, those are the things that people are actually willing to put money down on. And those are the things really that we want to talk about.
My question then is, or I guess let me say this. So I'm going to just let me just rewind. So for the technicians out there, if you remember 15 years ago, how so many techs were still just charging systems by suction pressure and beer can cold, and very few technicians do anything about superheat and subcool and vacuum gauges and all this sort of thing, and measuring static pressure. That was just almost unheard of, especially in the residential service environment, and how that's changed since then to where the majority of technicians at least know that this stuff exists. Whether or not they practice it or not is another question, but the percentages are increasing greatly. And those are all metrics. So measuring, superheat, subcool, suction pressure, head pressure, delta T, static pressure. These are all things that we're taking statistics on a piece of equipment to tell how that piece of equipment's working. We're taking all these measurements. And that's going to continue to increase on the technical equipment side. But I think it's going to even more so increase on the building side. And so for those of you who work in, large commercial, you know that when you install a new piece of equipment, you don't just wire it up and fire it up. It's not that simple. You do a commissioning or a thorough startup where you test every aspect of that system. Well, that's going to start coming into the residential side as well, not only, like I said, on the equipment side, but also on the building side, looking at the entire building, everything that's inside that envelope of the building is going to be part of that system that we are part of diagnosing. And really your involvement in that is going to depend on your knowledge of how this all works. Let's start with blower door testing, because a lot of technicians are super nervous about it because they have no idea what it is, and it's coming to a lot of states. I mean, even in Florida now, it's coming here in a couple months. So give us a quick rundown of what that is, why you would even test that, and what it can tell you about the envelope of a building.
Okay, so first of all, the blower door is the most important tool that you can use to diagnose any home or residential building, period. That's the first thing to understand. The reason for that is that it is the central tool to diagnose anything about the enclosure. And the enclosure, we already mentioned, is the most important system of the two systems in any home. The enclosure and the engines are the two, and the enclosure wins every single time. So for the HVAC people who are fantastic across the country, they could do a perfect job 100% of the time. But over the coming years, if the enclosure has a problem, your HVAC is going to be blamed for the comfort problems, for the noise problems, for the smell problems that are happening. But it's not your problem. It's the enclosure's problem. But if you don't know how to diagnose an enclosure problem, then you're going to keep taking the heat for these odor, smell, sound, comfort problems in people's homes over the coming years. And they're going to get worse and worse because homes are becoming more rigid. So the reason that blower doors are becoming more well-known is the codes. The code actually is going to come to every single state, all 50 states, within the next couple of years. There was a mandate from ARA, the American Recovery and Reinvestment Act of 2009, and the fine print said, states, if you take this money for the boosting of your economy, you have to meet 90% compliance by 2017 with the 2009 International Energy Conservation Code. That's the IECC. That code is the first one that stipulates performance testing. Blower door testing is mentioned. It's not required. You could do a visual inspection. And this should be really, really worrisome. If you are in a state that's on a 2009 energy code, which I am in right now, Georgia is one of the real laggard states across the country. 2009 code means that you, as an HVAC professional, have to put in your manual J software to calculate how big the furnace and air conditioner needs to be based on air tightness and window areas as the two huge things that are really overlooked in most manual J calculations. So if you're doing the heat load calculation, you got obviously the areas of the walls and blah, 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 the U values and the R values of the insulation and the ceiling, et cetera. But the air infiltration is a thing that you won't know if you don't have a blower door number. If the builder says, oh, we just do a visual inspection, that means no one looks at it, because really, honest to God, to do a visual inspection costs more than to do a blower door test. So you want to do a blower door test, period. Secondly, if you're going to diagnose anything later, you need the blower door as the central tool. If you're going to use infrared cameras, if you're going to use pressure panning, if you're going to want to do zonal pressure diagnostics, which I talk a lot about in my training, all that stuff requires that you are also using a blower door. Anybody who uses an infrared camera by itself cannot know very much about air leakage. Air leakage is the most important aspect of the enclosure. And if you're not using a blower door, you just can't know anything about that. So this is all why the blower door is the most central tool. And honestly, If you're thinking about getting into diagnostics and you have $2,000 or $3,000 sitting around, go ahead and buy an entry-level blower door. There's only basically 2 manufacturers. Don't worry about getting any bells and whistles, and just start using it, because talking about it and using it are 2 totally different things. The reason that you're become good at blower door testing is because you've done like 50 or 100 of them. And every time I do a blower door test, even though I've done, thousands of blower door tests at this point, I learn something about blower doors and about blower door testing and about homes. Every single time I do a test, it's amazing.
All right, so there's going to be a good portion of the people who are listening right now, though, who heard all that, like, that sounds amazing, but I still have no idea what a blower door test even is. So let's do just a basic summary of what it even is.
Here's how it works. You have a front door to every house. Let's just imagine, for the sake of argument, that this front door is rectangular, not arched. You're going to replace that front door. You're going to open the door, and you're going to put in place of where the door was essentially an airtight shroud. It's on a frame, so it's exactly door shaped, and you resize it for every single different door that you meet, because they're all different. And inside that door, you're going to mount, in this hole that's already in that nylon shroud, a fan. And the fan is one of the very expensive parts of this rig. The fan is scientifically calibrated, and it has openings in it, a bunch of different sized openings that you can open. The computer that you're going to hook up to that fan, the fan being the blower, the computer is called a manometer. It's a pressure gauge. It's generally a dual channel pressure gauge, and it's digital. Digital is very important because it's a much higher resolution. So the digital pressure gauge, the manometer, you're going to hook up to this thing. It's going to measure 2 things. Number one, it's going to measure the pressure in the home with reference to outside the home. And the reference of the outside is the thing that's not going to move. It's like an anchor. So essentially what you're going to do is drag the house interior pressure with all the doors and windows and all the intentional openings to outside closed and locked to be as airtight as possible, but all the interior doors open. So you've got one big room that is your house now. You're going to drag that pressure down 50 pascals south. That's basically 1/5 of an inch of water column. So it's not very much. Your ears are not going to pop. Don't worry about it. You're not going to hurt cats or dogs or anything like that. When you have the house depressurized, it's now the most depressurized place in the entire neighborhood. Now you're going to lock in that 50 pascals, 1/5 of an inch of water column difference, and you're going to keep the fan instituting that pressure differential. And then you can see how much air is going through the fan when you hold at that pressure. And the amount of air going through the fan, because 1 CFM in equals 1 CFM out, you can't create a vacuum. You know that if that much air is leaving the house, that much air must be coming in. And since we use 50 pascals as the oranges comparison, you can compare all houses like oranges to oranges. We know how much air proportionally is leaking in each and every house in every single neighborhood across the world, if you can compare them all with the same metric. So this CFM at 50 pascals means the amount of airflow through a fan when you hold the house at 50 pascals pressure differential to outside.
All right, so I want to talk quickly in our tooltip corner about manometers. So manometers are probably like the entry-level tool/drug into building performance, because it's something that every AC technician should have on their truck. Obviously, if you ever are measuring gas pressure, a digital manometer is the best way to do that. And then you can also use the manometer to measure at the most basic level static pressure. You can also use it with a pitot tube to measure air velocity, total pressure, and static pressure. So there's a lot of different things that you can do with a manometer. And there are different levels of manometers. In fact, Testo has a couple different levels. They have their 510i, which works along with the Smart Probes app. They have their 510, which is their basic little handheld dual port manometer. And then they have the 512 series, which they have a high pressure version and then a very, very fine, very sensitive version of that. And there's a whole range of different manometers made. If you saw my recent video on the Testo 420, their flow hood, they actually have a really high quality manometer built right into that flow hood that you can remove and use for different measurements. And so Corbett talks a little bit about static pressure and different pressure differentials and how a manometer is used with a blower door. But the one thing I want to mention, because this is something that comes up when techs are first starting to use a manometer, and I wrote an article about this, but something to know is when you're measuring total external static pressure, total external meaning the total pressure that's on the appliance. So when you're using the the fan charts for a furnace or for a fan coil, you need to measure on both sides, so top and bottom, of the actual appliance that comes in the box. So in the case of a furnace, the appliance that comes in the box is just a furnace. Doesn't come with a filter in most cases, doesn't come with a case coil. So you need to measure just above the furnace and just below the furnace, above the filter. In the case of a fan coil, it comes with the filter and the coil in the box. So now you read below the filter and above the fan coil. That's an important distinction to make for that particular type of reading, and that reading is when you are looking at the fan charts to see how much CFM you're producing or how to tap your X13 motor. There's a lot of different reasons you would do that, but that's what total external static pressure is. But there's something I want to mention, because a lot of technicians will utilize total external static when they're going to old systems. They'll talk in terms of total external static. When you go to older systems, I would much rather you just look at pressure drops across different parts of the system. So pressure drop across your evaporator coil, pressure drop across your filter, pressure drop across ducts, and then look at your supply and return static in order to see where possible diagnostic issues might be. Another thing to look at is you need to still look at your blower wheel, because if your blower wheel is dirty, you're going to have lower static pressure. So if you go up to a system, say, that was set up and it was commissioned properly, and then you come to it 10 years later and you're running lower static pressure, that could very well be just because the blower wheel itself is getting all crudted up, and if that blower wheel doesn't move air, then you're not going to have static pressure. The intent here isn't to go all into static pressure, but more than anything else, you need to make sure that you're looking at everything. You're looking at your filters, you're looking at your coils, you're looking at your ductwork, you're looking at your blower wheels. You know, it's okay to pull out the fancy tools, but you got to do all these things together. If you are going to have a manometer, which I would highly recommend that you do, and if you are going to measure static pressure, which I highly recommend that you do, then it's good to use a high-quality digital device in addition to some really good visual diagnosis, especially for things like blower wheels, because you're not going to see, that's not going to show up in your static pressure. In fact, it's going to make your static pressure go down instead of up if you have a dirty blower wheel. And the products that I use are the Testo products, the Testo 510i. That's something I have in my bag. I say I have it in my bag. I just handed it to one of my technicians who his broke, so I probably don't have it in my bag today. But then the 510 is also a great option. Here we go, back to Corbett Lunsford.
Now, the thing in the code that you're going to see is air changes per hour at 50 pascals. And that takes a little bit of math. You have to figure out what the volume of your house is. And this is why, in my opinion, one-day blower door crash courses are not a great idea, because to be perfectly honest with you, most professionals out there are not using geometry on a normal basis. So if you have to calculate what the volume of a space is, and you've got some triangular, like gabled areas, and you've got a tilted, roof line at some point, you have to do some math. You got to do takeoffs. You got to graph out what the house looks like. You can use apps for this. I've got a bunch of them that I use. And then you have to do math to figure out what the volume is, and you put the volume into that equation with the CFM, and you can figure out how many air changes per hour. If you kept on keeping the house at 50 pascals, how many times all of the air inside the house would be replaced. And that's one of the reasons, by the way, that you don't want to run a blower door when you're doing an infrared scan for like an hour, because when you're a beginning infrared thermographer, you're going to be taking your sweet time with that thing, because the pretty colors are amazing and it makes you move really slowly. So you could literally replace all of the air, like in my condo that we used to live in, it would be like 20 times. You would replace all the air inside my condo 20 times if you ran that blower door for an hour. That means that my furnace now has to warm my house back up from 30 degrees, which is what it is outside. You want to be real careful about the tool. The tool itself is very dangerous. You can set a house on fire with it. If the water heater were to accidentally kick on while you're running your test, air is shooting down that chimney and it can cause flame rollout, ruin a water heater, or set the house on fire. You could bring sewer gases into the house. You could do all kinds of bad. So please be careful. If somebody says, hey, you want to borrow my blower door and start using it? Please go. First of all, you can read my book for free at homeperformancebook.com. Just read the blower door chapter and know what you're getting into. There's a bunch of prep steps that you want to make sure to do. And then also make sure that you have somebody in your local area that knows how to use this thing, and maybe get some hands-on training with them, because it is a touchy instrument and you can do some funky stuff to houses.
Yeah, and actually measuring the volume inside of a house is a lot easier than people think. All you have to do is you just have to fill your entire house with water and then measure the water when it comes out to tell the volume of the inside of the house. I don't know why you don't mention that in your course.
Which you could technically use the blower door to do, actually. That's a really interesting application.
Yeah, so don't do
You could also use marbles.
marble packing peanuts. I've seen people use packing peanuts as a way. Balloons, possibly. I'm sorry, this is not going well. Okay, but the
There
point.
should be. Is there going to be a sound effect there?
I need to. Yeah, I need. Shoot, I'm really slow on the sound effects. Like I need to figure out. Like whenever I do a joke, I need to use this one right here a little bit more often. But I'm really slow with it. So the point here is that what Corbett, I think, is saying to you technicians out there is you don't want to grab a blower door and just start doing it without kind of knowing what you're doing a little bit. So maybe first do it on your own house. So if you're going to drag in some sewer gases, you can at least do it on your own place. Get used to it. Work with a local raider, somebody who already does this sort of thing, and start to develop a skill set. You don't want to just hand it to one of your technicians and say, "Hey, go use this blower door." It's not like that. It's not like a set of gauges or something in that regard.
And speaking of that, by the way, for the companies that do have a bunch of employees, don't try to get everybody nominally skilled at the blower door or something like that. Have like one person at your company whose job becomes diagnostics, because the way that you think about diagnostics kind of transforms your brain. You start thinking on two planes at the same time. You think about relationships of things in the house and also sequence and consequence. And the way of thinking is not a totally normal thing. If you've got a bunch of guys running around trying to do change-outs, trying to do service calls, they're not thinking in that way already. So trying to make that happen is going to be like herding cats a little bit. So get somebody really versed in diagnostics and then expand from there.
Here's a random question that just popped into my head. So if you had a choice between somebody who had more of an accountant mind, very detailed, very deliberative, good at math, or somebody who had more of a technician's mind, very qualitative, diagnostic, this causes that kind of mindset, but maybe not quite as detailed, who would make a better home diagnostician?
That's interesting. I actually, when you said accountant, I actually, as a musician, in my former career, I knew a lot of musicians who were actually accountants at heart. And so I think of it kind of as a line between creatives and accountants, people who are like, try to think about creative ways to put things together, and accountants being people who are like they like rules and being restricted by this is the way we do this every single time. And I'll say that there's a bunch of both in the field. And what I like about the way that I get to approach my work is that I am definitely a creative. I am not an accountant type of a person. When I approach a home, I used to be BPI certified, HERS certified. I ran a HERS providership. I have been certified, like if you think of a home performance certification, I've definitely studied for it and had it because I really felt like I needed that cred. Now I need it less. And also I've learned that if I use a standard that is a one-size-fits-all protocol, I will become a one-size-fits-all customer service person. And I call my customers clients because clients is a little bit more higher class. So when I'm serving a client, I like to really customize the diagnostics I'm using, the approach, the way I'm explaining what I do. If I have somebody who's a NASA scientist versus somebody who's a kindergarten teacher, I'll explain the thing very differently. You can have either mindset. You will end up being good at something. Like there are some companies that do blower door tests for cheap, and they do just blower door tests all day long. Those people probably wouldn't be good if you were a creative type person working at that company. They don't need that kind of a person. They need the accountant-minded person to work there, to do that job. I am more on the creative side of the spectrum, where I get to kind of play in both systems, and I get to make up my diagnostics, and I get to, format my reports differently every time and do a different kind of service package. So I think we need both for sure. If you want to have more fun, you should get the creative minded person, because if you're all about problem solving, creative mind is what you need. If you're all about like production and working and coming up with the same exact package every single time, then an accountant mind is the one that you would pick.
Yeah, and see, here's the challenge. Like, it depends completely on how you describe yourself, whether or not it sounds fun to me or not. When you describe, like, I'm a building forensic analyst, or like a building detective, or a building diagnostician. See, that sounds like fun to me. I like all that stuff. But when it's like, yeah, you've got to use an app and take calculate the internal area of a building, using geometry, I'm like, oh my gosh, I never want to get into that business. So I think a lot of technicians are probably there, where the idea of using diagnostic equipment, understanding buildings, coming to solutions and conclusions, and bringing those solutions and conclusions to reality sounds like a lot of fun. But technicians are usually really bad at math, and like super detailed calculation and documentation is usually not something that technicians are great at. And I just wonder if a large majority of technicians will be able to overcome that. And this is me totally thinking out loud here. I'm just struggling with it. Even when I'm doing something simple like a manual J, if I'm going to do a room-to-room manual J, I feel like my eyes start to bleed after about 37 seconds. There's probably no answer to this, but do you have any thoughts about that?
I mean, I think about this stuff a lot, clearly. So I would say a couple things. I'd say, number one, if you dream of owning your own business someday, a part of that dream should be taking out the trash yourself, because like that's what happens when you're a business owner. You do all the crappy stuff. But also, I guarantee that diagnostics is more interesting than almost anything that you could do, because it's like you find something out and you're doing something that no one else will ever do in that house. So like, honestly, even just measuring, like what you said, Bryan, no one else is going to measure the house as precisely and as interestingly as you will. No one else is going to measure the volume of that house. So you now are this wizard who knows things about this house no one else will ever know. It's kind of interesting. So that's the one thing. The other thing is that if you want to do interesting work, and I don't want to get all philosophical for a minute, but like I'll just tell you that right now I have a client who is building, if you will, hobbit houses. They're like earth berm houses. Basically, you take a fiberglass pool, you turn it upside down, cover it with dirt, and they're trying to make sure that it's comfortable, that it smells nice, that it's humidity controlled, that it's going to be sounding perfect, that you're not going to have environmental sensitivity problems down there. That is a fascinating job. And I actually took an entire day to do that manual J, because I had to do this curved wall assembly. And also dirt, like how are you going to calculate the R value of dirt? So all that stuff was really fascinating to me. And I wished I actively, like got to the place where I'm like, okay, I can do a manual J for a normal house all day long. That's like, I'll do it, but I'm not that excited about it. What I really want is freaky clients who has problems that are like nobody else wants to deal with. Those are the ones that I really am excited about. And also, I will remind you that I was a piano player for ballerinas, and I used a calculator to do addition with before. Now, because I've learned to like use math and to do geometry, and I've learned all the shortcuts, I never went to calculus class. I wasn't good at chemistry. I'm not really that kind of a technical. I am a technician, but I'm not a really good math person naturally. Anyone can learn anything if you just put your mind to it. And what's really fun is learning how math and geometry and calculating volumes can really give you an edge. If you can actually sit down with your client and do math on a napkin in front of them without a calculator, they are blown away. And once you see that you are really knocking somebody's socks off with a diagnostic that you're running, or even just measuring their house, like honestly, I've got my phone in my pocket. I have an app called RoomScan. And if you want to wow your client, download this free version of RoomScan and start measuring their house with your phone. And it goes beep. And then you walk over to the next wall, it goes beep. And they are like, what are you doing? This is amazing. So it's that reaction that I think a lot of technicians don't get, because you're in the basement, you're in the crawl space, you're in the attic. Your client is not watching what you're doing. They know that you showed up in a hurry, breathing heavy, your shirt was untucked because you have a really hard job. And you suddenly start showing people what it is that you're doing and how good you are. It's amazing the flood of adrenaline that you get knowing that you are a god of the house. Like they'll call you 6 years down the road and just say, hey, how does my attic work again? I can't remember. And I know that you know the answer. That is the thrill that really gets under your skin with this.
All right, I'm sold. Okay, so now how does it? So a technician, a technician who thinks, okay, I think I want to start walking down this path, or say a business owner, contracting a company business owner, and says, okay, I want to start going down the path at least to being prepared for this new wave that's going to come along with building performance. Where do you suggest they start? What's step one?
Well, first of all, you're going to have to sell your team on it. The easiest way to do that is that you will not have callbacks if you measure your own work. So let's just say, for example, just because this is what's required by code, duct tightness, right? Everybody has to be installing new ductwork in additions, in renovations, and in new construction so that it's tight. And this is not dumb, and this is not a fad. Ducts are plumbing for air. You do not want them leaking, because the whole point is to take the conditioned air from the conditioning device, the air conditioner, the furnace, to the room where you want it to go. If it leaks out in the wall cavity or in the basement on the way, it does no one any good. So duct tightness is important. You install a duct system, you think it's tight, but you don't know until the guy shows up and he charges you $350 to do the duct tightness test, and you fail. And you fail by a lot. enough that you're not going to fix it today. I'm not going to stick around. What's going to happen is you tell me when you're done sealing, and I will come back and I will charge you again the exact same amount of money. You may fail again. And I've had this happen before where people fail like 3 times in a row and they end up being out of pocket a huge amount of money, super pissed off by the end. They actually say, you know what, I'm just going to aero seal everything from now on. And I don't want to think about this ever again because it hurt my feelings so bad this first time. So if you own your own duct tightness tester, which is not hard to do, it's another, $2,500 item. It's pretty quick. You can learn this kind of thing in 2 days in a training, and you test your own work. Your company knows when you leave that site, you will not be back. You will not be paying for an extra test. You will not have to go back and uncover a bunch of stuff and put more mastic onto collars that you missed. You've actually found the problem and you have fixed it before you left. Now you have the confidence of knowing, hey, we can keep on doing our jobs and move forward because we will not be moving backward to that thing. Also, you avoid people being disappointed in you. You avoid having employees who don't know whether they do a good job or not. You avoid having to guess whether your employees are doing a good job or not. You actually have the proof of which of your team members does a great job. Who's the A team on duct sealing? And then, as you move down the road, who's the A team on delivering the right static pressure, on building the ductwork the right way, on designing this stuff properly. So you actually have this feedback mechanism where man, we do a great job. And now it gives you more confidence with marketing and also metrics to market with. Because if you were to plaster all over town a billboard that says we are scientifically proven to be the best HVAC company in town, ask us how we know that. You'll have people call you because it's not about opinion at that point. It's about fact. You are not stating your opinion that you are the best. You know for a fact you're the best because you measured your own work and you've measured other people's work because you know who they are since they put their sticker on the plenum, and you keep a track of, what kind of work everybody does, static pressure wise, airflow wise, duct tightness wise. And now you have this ability and this competence that no one else is going to be able to match. It's just amazing how people talk about this a lot, but very few people actually do it.
So let me paint a picture for you out there in Radio Land. If you want to stare into your pretend fire, maybe you could open up the Fireplace app on your phone and stare into it. So I'm going to tell you a story here. So think about if you, as a company, you start every piece of equipment you install. So whether it's a change out or whether it's a new construction building or a renovation or whatever the case may be, and you start checking your static pressure on every system. That's simple. A lot of you are already doing that. So you're verifying that your duct system is not too resistant to airflow. And so that's a good start. But then in addition to that, you start doing duct tightness tests. A lot of you may know that as duct blasting or using a duct blaster, which is a brand name. But you start doing duct tightness tests so you can tell what your duct leakage is. You start doing blower door testing so you can tell how tight the envelope of the house is. You start measuring ventilation to make sure that you're bringing in proper fresh air and you're expelling the proper amount of air out of the space. You start doing air balancing so that you're ensuring that you're delivering the proper amount of airflow and providing the correct amount of air changes to every room in the house. And you start measuring delivered capacity so you know how many BTUs you're moving inside and outside of in and out of the home, I should say. So you start doing all of this. Is there anybody in your market who competes with you at that point? So I'm asking the question to the people in Radio Land, and they're answering me, but I can't hear them. But the answer is no. You don't compete with anybody once you start doing that, and that's the future that I see for air conditioning contractors, which is really the entire spectrum of not just like what Corbett said, not just energy efficiency, although that's one factor, but more importantly is just how people feel in their home. And it starts with just the confidence to know that their home is clean and dry and safe for them, that they're not going to have mold growing in their walls, and that their kids are going to be able to sleep well, and that their air is not going to smell of, stinking sewage or whatever the case may be. It's all of those things that people do care about. And maybe not everybody, but as the government and regulatory bodies start to make this more and more important to our jobs, why don't we start thinking about it proactively instead of reactively and start to become the experts in our industry? I'm done with the soapbox now, so you can add any commentary to that you like, Corbett.
Oh, I think that's great. Yeah, that's exactly the point. Is I think every single contractor in all of construction and all of home improvement should be measuring something. I think that home performance testing ninjas like me, who are only do testing, are not as necessary everywhere. We only need like 1 or 2 of those per metro area, because really we're really for the specialized weird cases. Everybody could find out that the air leakages through the attic in the top plates, or that the air conditioner is not working properly on airflow. Any air conditioning company, if they had the right equipment, testing equipment, and they had the right training, could diagnose both the enclosure and the HVAC system. And you guys are in the house twice a year, ideally. And by the way, we're going to be telling people on television next year with our TV show, which is going to be on PBS. It's called Home Diagnosis. It's basically This Old House meets CSI. So please watch out for that. But we're going to be telling people that they should, of course, have their HVAC system serviced. And if you're there and you're owning both the enclosure and the engines, you have an amazing opportunity to keep that client and to keep them coming back to you for anything that they're going to do with fixing problems, with improving their home, or with building or buying their next home. Even if you just want to be a consultant and you don't want to work on new construction, they will absolutely hire you to do the manual J as a second opinion over the company that they want to work with. So if you don't want to work on new construction, you don't have to, but there's a bunch of opportunities within construction and home improvements with testing.
For those who want to know more about what you do and want to learn from you, what are some of the best ways for them to do that?
Great. Well, our website is buildingperformanceworkshop.com, and that's where you can get access to all of the different blog posts that we do. And right now I've got people, we're in the middle of it. Right now, we're going to have another one in the fall, but we've got people from abroad as well. We've got somebody from Bolivia and somebody from Ireland in it, which I'm really excited about because internationally, we think, oh, maybe America's behind. America's not behind. Everybody's behind. So that's a really exciting thing. And then also our YouTube channel is called Home Performance. You can go to youtube.com/c/home performance and see any of the episodes there. And if you want to hear an amateur hour podcast about building performance, you can hear Building Performance Podcast, which is my version of what Bryan does much better.
All right, so let's see if I have any sway over my listeners, because so everybody listening to this who appreciates what I do, and you know that I give it out there for free. I want Corbett to like me. I have a lot of insecurity, and I want him to like me. So if you could go to his podcast, have a listen to it, and then give him a rating and review, telling him that you heard him first on the HVAC School podcast and how amazing his podcast is, and maybe compliment some sort of physical feature of his, that would be acceptable to me as well. And hopefully then he will come back to the podcast regularly and be our building performance expert here on the HVAC School podcast.
I would love to come back anytime, Bryan. It's been a real pleasure. Thank you.
All right. Thank you, Corbett. All right, thank you all for listening to the HVAC School podcast. If you do not subscribe to the podcast, if you have an Android phone, then go to the Stitcher app, download the app, type in HVAC in search, and you will find the HVAC School podcast. Subscribe there. If you have an iPhone, go to the podcast app. It's already on your phone. Looks like a purple radio tower. Go into that app, type in HVAC, find the HVAC School podcast, and subscribe there. That way you won't miss any of the future episodes. I really want to thank Corbett Lunsford for coming on. He actually is somebody I really wanted to have on. He's a great communicator and just a great human being. And so thank you to Corbett. You are going to want to watch out for his new show coming out on PBS. I believe it's coming out either late 2017, maybe 2018. Don't quote me on that, but just keep an eye out for that. I will tell you that Corbett was a little bit impatient with how long it took me to put this episode up. Sometimes my production speed isn't as quick as it could be. And so I called him up, and he just assumed the show had been canceled.
Well, looks like the show's been canceled again.
Okay, none of that was actually true. Thanks for being here at the HVAC School podcast. See you next time.
Thanks for listening to the HVAC School podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School podcast.